Welcome, Mr. Sutton here, bringing you the Pre-Cal Honors 2-5 Part 2 homework solutions on graphing polynomials in standard form. To graph this polynomial, we're going to have to find the roots, which means we're going to have to factor this thing out. So factoring this, it looks like this is in quadratic form. We've got fourth power, second power, followed by a constant. In this form, we can actually factor this like we would a normal quadratic, but we're going to use x squared instead of x when we break it down. So I'm looking for two numbers that multiply to 81, so factors of 81, that add up to negative 18. So let's see here, 1 and 81, no. 3 and 27 doesn't work. 9 and 9 does, though, negative 9 and negative 9. So I can split this up into x squared minus 9 and x squared minus 9. Okay, well, I can actually split this up a little bit further. X squared minus 9, that's really an a squared minus b squared situation, the difference of two perfect squares. So I can split that up into a plus b, a minus b. So taking the square root of these two terms, we've got x plus 3 and x minus 3. And since there's another x squared minus 9, we can do that again and have another x plus 3, x minus 3. Now we're going to actually go ahead and collect these ones that are the same. These two x plus 3's, if you multiply them, that's really x plus 3 squared. And then this is an x minus 3 quantity squared as well, because there was two of those. And now that we've got it set up like this, this is the totally factored version. We see that our roots, what zeroes out each of these factors, is going to be x equals negative 3 and x equals positive 3. Let's go ahead and put those on our graph. So we've got negative 3 over here somewhere and positive 3 over here somewhere. And I also can find my y-intercept pretty quickly. In standard form, that's just the constant at the end that would be left over if you plugged 0 in for all the x's. So that's just 81 in this case, which is going to be somewhere here above the x-axis. Now for my end behavior, I look at the lead coefficient of the original here, this x to the fourth. That is a positive x to an even power, which tells me that this is going to behave like an x squared, like a right side up parabola. So we're going to start above the x-axis and end above the x-axis. And the only other thing I need to look at is my root behavior. So looking at these factors here, they're both second power factors, which means negative and positive 3 are both double roots. So that means we are going to bounce like an x squared when we get to negative 3 and positive 3. All right, well, let's go ahead and see what happens here. So we're starting above the x-axis. We said we're going to bounce off negative 3, go through our y-intercept of 81, come back down. We have to bounce off of positive 3, and that means we end above the x-axis, which is what our end behavior said we would be doing. Before we can graph this polynomial, we need to factor it so that we can get our individual roots out of this. So I can't take out any common factors, but I'm going from x to the fourth to the second power to a constant. This is quadratic form, so I can factor this just like a regular quadratic, but I have to use x squared instead of x when I break it down. So I need factors of negative 4 that add up to positive 3. So let's see here, 1 and 4, that would do it if I had negative 1 and positive 4. So I can write x squared minus 1 and x squared plus 4. Now this x squared minus 1 can get split up. This is a squared minus b squared, basically. So you can break it up into an a plus b, a minus b situation, just square root each of these. That gives us x plus 1 and x minus 1. Now this x squared plus 4, this is the sum of two squares, not the difference. We know that we can't factor the sum of two things in this situation. In fact, if you think about it, if you tried just setting this equal to 0 and solving, you would be subtracting 4 and then square rooting. So you'd basically be square rooting a negative, getting imaginary numbers. So if you can't get actual real numbers out of this, there's no way you're going to be able to factor it anyway. So I'm just going to rewrite that so I don't lose it. So now setting the other factors equal to 0 and solving, we have x equals negative 1 and positive 1. And again, we don't get any real roots out of this last parentheses. It's just kind of there. So putting the ones that we can get on our graph, we have negative 1 to the left of the y-axis, positive 1 to the right. And we also have to look at the y-intercept. So if you plug in 0 for x, you're left with this constant of -4 at the end. So that's our y-intercept, and that's somewhere down here below the x-axis. Now for end behavior, looking at this lead term of x to the fourth, that's a positive x to an even power. So that means this is going to behave like an x squared, like an upward opening parabola. So in other words, we're starting above the x-axis, and we're going to end above the x-axis. Now, in terms of what happens in between, the -1 and the +1, those are both coming from single power factors. These are single roots. So we're going to cross through both of those like a line. And let's put it all together now. So starting above the x-axis, we cross through -1, go through our y-intercept down there at -4, come back up and cross through +1, and we end up above the x-axis, just like we said we should with that end behavior. And I mean, this looks like kind of a simple graph for something to the fourth power, but some of these do look like parabolas. Now, if you wanted to see the individual twists and turns that are on this actual graph rather than just a sketch, you would need some calculus to see a little more detail, but for our purposes, this is going to be enough. To graph this polynomial, let's begin by factoring this so we can get intercept form, which will make it easier to figure out the roots. So I can't take out any common factors from this whole equation, but it looks like I can factor by grouping since I have 4 terms here, or I can at least try to group. So let me start by taking a common factor out of just these first 2 terms. These both can give me an x squared, and then leaving me with an x minus 5 inside. And for the next 2 terms, I can take out a -4. That'll leave me with an x minus 5 inside that. Now, I have this common factor of x minus 5 that I can take out of everything, and that leaves me with x squared minus 4 as the other factor. Going a little bit further, I'm just going to rewrite that x minus 5 factor, and then x squared minus 4, well, that's a squared minus b squared. I can square root and split that up into x plus 2, x minus 2. And now I can get my roots out of this. Setting each of these equal to 0 and solving, I have roots of x equals 5, -2, and +2. Let me put those on my graph at this point. So -2, somewhere over here to the left of the y-axis. +2 is over here on the right. And +5 is even further to the right. For the y-intercept, if you plug in 0 for x, you get this constant in the original here of 20. So that's 20 for the y-intercept, somewhere up here. And for the end behavior, looking at my lead term of x cubed, I have a positive x to an odd power. That means this is going to behave like an upward sloping line, like a y equals x kind of graph. So we're beginning below the x-axis, ending above the x-axis. For the root behavior, all of my roots are coming from single power factors, so I'm going to cross through all of those. So starting below the x-axis then, we're just going to cross through -2, go through that y-intercept of 20, cross through +2, come down, go back up, and cross through 5, and we end up above the x-axis, which is where our end behavior said we would end up. In order to graph this polynomial, since we're in standard form, we're actually going to have to go ahead and factor this to get the roots. So all I can really factor out of here is an x, well, actually x to the 3rd power, since that's our lowest exponent. So if I take out an x cubed, I have an x squared minus x to the 1st power, or just x, minus 12, and that's what's left inside. And this quadratic can get factored a little bit further. So I need factors of -12 that add up to -1. So let's see, 1 and 12 doesn't work, 2 and 6 doesn't work, 3 and 4, if I have +3 and -4, that would add up to -1. So let me rewrite this with the x cubed out in front still, but now I'll split this up into x plus 3 and x minus 4. And now I can set each of these factors equal to 0 and solve for my roots. So if x cubed equals 0, then x equals 0 is one of my roots. And I also have x equals -3 to 0 out that second factor, and 4 for that last factor. Putting it all on the graph, I've got -3 somewhere to the left of the y-axis, 0 is on the origin, and 4 is somewhere to the right over here. For the y-intercept, well, we already graphed it because we have an x-intercept at 0, but that's also on the y-axis. And of course, if you plugged in 0 for x, you'll see that that zeroes out everything on the right side here anyway. So 0 for the y-intercept. For the end behavior, looking at our lead term of x to the 5th, that's a positive x to an odd power. So that's going to behave basically like y equals x, like a upward sloping line. So we're beginning below the x-axis and ending above the x-axis. For the root behavior, looking at -3, that's a single power factor, so a single root, so we're going to cross through -3. The next one, 0, that came from this x cubed. That's a triple root, so we're going to cross, we're going to flatten. We are going to cross, but we're going to do so in a flattening manner through 0. And then at 4, that came from a single factor, single power, so that's going to be just crossing without flattening at 4. So starting below the x-axis, again, we're going to cross through -3, come back up, come down, and flatten through 0. And then we're going to cross through 4, ending above the x-axis, exactly where our end behavior predicted we would be.